So now we're going to look at three examples of specific Mirror Lab implementations that replicate particular network environments. The first here is an operator who wants to be able to test their two-vendor 4G implementation in the lab, where each vendor has two different configurations. It looks like vendor A is used in high-density areas with two-carrier aggregation, with both CRAN and DRAN configurations. Vendor B is used for lower density sites, perhaps rural areas, and only single carrier deployments, but they also have both CRAN and DRAN configurations. The next example is a 5G operator that's replicating their dual split implementation in the lab. It looks like we have a 5G site on the left there in a split 2 configuration, which is suitable for delivering service in places where the mid-haul performance isn't great, like maybe a rural area. It could also be for delivering higher capacity services where you need some baseband processing near the edge, such as high traffic areas or in buildings. The right-hand side is a 7-2 split, maybe using mid-band spectrum because I see 4x4 MIMO here. These are probably for wider area coverage needs. And the third example is an operator that has both 4G and 5G networks running simultaneously and wants to replicate interoperability in the lab. The 4G network has a combination of 4x4 MIMO sites and some 2x2 MIMO sites, presumably to represent a mix of high and low density deployments. The 5G network is split 7-2, which is reasonably cost-effective architecture, especially with the virtualization of the CU and DU, as we see here. So it's possibly a 5G overlay to a 4G network. These Mirror Lab implementations are set up to allow the testing of all types of customer services on each of their network configurations, including the actual RF designs that exist in the field. They enable roaming and handover testing between and among any combination of the operator site configurations. The number of RF shield boxes determines the number of simultaneous tests, and each of them can share all the same network resources. Obviously, these aren't the only options. The combinations are almost endless, but the idea here is to implement a representative sample of the production environment in the Mirror Lab so that all real-world scenarios can be tested and performance validated. To expand on the examples we just looked at, we could imagine an even more sophisticated Mirror Lab that combines all these network architectures together. By combining the outputs of the various switch matrices together into the same set of RF chambers like we see at the bottom here, we can replicate a single network with all these different configurations and implementations. The user equipment in these shield boxes can make calls on and be handed off between any of these networks,